Hi, I'm Torben Jansen, and this video is the second part of my SQL result set mapping video series. We had a look at some basic result set mappings in my previous video, Result Set Mappings, the Basics. You will find it here. I recommend watching that one first. In this video, we will define more complex mappings that can map your native query result to any combination of entities or entities and additional scalar values. But before we proceed, if you're new here and you want to learn how to create your entity mappings with ease, build incredible efficient persistence layers with Hibernate and Spring, and all types of other Java persistence-related stuff, subscribe and click the bell to get new videos every week. And please give this video a thumbs up if you learned something new. Okay, before we dive into the mappings, let's have a look at the entity model that we will use for the examples. We used the author entity with an ID, a version, a first name, and a last name already in the first video of this series. For the more complex mappings, we need the additional book entity, which has an ID, a version, a title, and a reference to the author. To keep it simple, each book is only written by one author. In real-life applications, we often select multiple entities with one query to avoid the additional queries that would be required to initialize lazy relations. If we do this with a native query, or stored procedure call, we get a list instead of entities. We then need to provide a custom mapping that tells the entity manager to which entities the object array shall be mapped and how this is done. In our example, we could define a query that returns books and its authors in one query. As the author and the book table both have an ID and a version column, we need to rename them in the SQL statement. I decided to rename the ID and version column of the author to author ID and author version. And the columns of the book stay unchanged. Okay, so how do we define a SQL result set mapping that transforms the returned list of object arrays to a list of fully initialized book and author entities? The mapping definition looks similar to the custom mapping that we defined in the video about basic result set mappings. As in the previously discussed mapping, the SQL result set mapping annotation defines the name of the mapping that we will use to reference it later on. The main difference here is that we provide two entity result annotations, one for the book and one for the author entity. The entity result annotation looks again similar to the previous mapping and defines the entity class and a list of field result mappings. If you don't like to add such a huge block of annotations to your entity, you can also define the mapping in an XML file. As described before, the default mapping file is called orm.xml and will be automatically used if it's added to the metainf directory of the jar file. The mapping definition itself looks similar to the already described annotation-based mapping definition. Now we have a custom result set mapping definition that defines the mapping between our query result and the book and author entity. If we provide this to the createNativeQuery method of the entity manager, we get a list of object arrays. Okay, that might not look like what we wanted to achieve in the first place. We wanted to get rid of these object arrays. If we have a more detailed look at the objects in the array, we see that these are no longer the different columns of the query, but the book and author entities. And as the entity manager knows that these two entities are related to each other, the relationship on the book entity is already initialized. Another very handy feature is the mapping of additional columns in the query result. If we want to select all authors and their number of books, we can define the following query. So how do we map this query result to an author entity and an additional long value? That is quite simple. We just need to combine a mapping for the author entity with an additional column result definition. The mapping of the author entity has to define the mapping of all columns, even if we do not change anything as in the example here. The column result annotation defines the name of the column that shall be mapped and can optionally specify the Java type to which it shall be converted. I used it to convert the big integer that the query returns by default to a long. As before, this mapping can also be defined with a similar-looking XML configuration. If we use this mapping in the createNativeQuery method of the entity manager, we get a list that contains the initialized author entity and the number of her or his books as a long. This kind of mapping comes quite handy if your query becomes complex and the result has no exact mapping to your entity model. Reasons for this can be additional attributes calculated by the database, as we did in the example here, or queries that select only some specific columns from related tables. In the first video of this series, we had a look at some basic ways to map query results to entities. But this is often not sufficient for real-world applications. Therefore, we created and saw some more complex mappings in this video that can map a query result to multiple entities by annotating multiple entity result annotations, and can handle columns that are not part of your entity with the column result annotation. In the following video, we will use the constructor result mapping that was introduced in JPA 2.1 and have a look at some Hibernate-specific features. Okay, that's it for today. If you want to learn more about Hibernate, you should join the free member library. It gives you free access to a lot of member-only content, like cheat sheets and ebooks, that help you to use JPA and Hibernate more efficiently. I'll add the link to it to the video description below. And if you liked today's video, please give it a thumbs up and subscribe below. Bye!